Yeah, so just a very quick presentation about some trends that are reshaping the emissions data that is available today. Many of you are probably familiar with grid emissions data through Scope 2 accounting. Maybe some people are using it for carbon-aware load shifting. And in the context of electrification, grid emissions data is also important for understanding when switching from on-site combustion of natural gas, for example, to using the electric grid is going to have lower emissions. If you're just running off of natural gas being generated somewhere else on the grid versus a cleaner grid than what you can achieve on campus by switching and electrifying on campus. But yeah, so I want to talk about the four trends because grid emissions data has changed a lot in the last few years, and the data you're used to probably looks nothing like the data that's currently available today. So the first trend is that yesterday's data that you're used to is probably annual resolution. There's a single number that you're using for the entire year, which doesn't really provide a lot of insight into how carbon intensity changes throughout the day with renewables as they generate. And so today's data that is available is now hourly or better resolution data, and it helps provide insight into what times of day or which seasons are cleaner or dirtier on the grid. And I'll point out too that some of the research that helped explain the value of this hourly data was actually done here at UC Davis as well. The second trend is that is related to the recency of the data. So the data you're used to probably is several years old at best. It's published a few years after the fact, but with the pace of change with today's grid, grid emissions data from 2 years ago probably is not reflective of the carbon intensity of the grid today. And so today's data is now available in near real time. This is actually a screenshot from just a few minutes ago showing the carbon intensity in California nearly up to the minute of the grid. And that can help make more informed real-time decisions about what is actually happening on the grid in real time. The third trend is that is related to what the data is actually describing. Previously, grid emissions data described the average carbon intensity of the electricity generation fleet, but that doesn't necessarily reflect the carbon intensity of the electricity that's being consumed in a region. And that's due to the fact that there may be imports of electricity into a region from other areas, and that imported electricity may be dramatically cleaner or dirtier than the electricity that's being generated nearby. And so today's data is actually focused on electricity consumption and explicitly accounts for those imports and exports of electricity, and thus the exchange of emissions between regions as well, which can give a better idea of the carbon intensity of the grid and the electricity that you're actually consuming on site. And the fourth and final trend is that yesterday's data, the data you're probably used to, is available at kind of a broad regional level, assuming that the carbon intensity of electricity is the same across the entire region. However, today we know that due to power flows on the grid, that the carbon intensity of electricity can actually be different from one node to another, from one city to another. And so I'm not saying that this is today's data because this is still a little bit on the horizon, but one of the things that we're working on is working with grid operators to unlock nodal level carbon intensity data to help provide differentiated insights into the carbon intensity of electricity in specific locations of the grid. And so if you want to check out any of this new data, of course, there's a lot of commercial data providers that provide this, but there's a couple of great free resources, public resources for looking at this kind of newer data. One is the Open Grid Emissions Initiative, which is actually a research project that was started at UC Davis in collaboration with the US EPA. That's a completely free, open source, open data that has hourly grid emissions factors. Think of it kind of like an hourly version of eGrid. And the second resource is the EIA's Hourly Electric Grid Monitor, which provides near real-time data about the fuel mix on grids across the US, the continental US, as well as consumed emission rates for those regions as well. So yeah, hopefully that was a quick introduction into how grid emissions data is changing. and feel free to reach out if you have any further questions.